In this video, you will learn what covalent bonding is. Covalent bonding is a chemical bonding which involves the sharing of electron pairs between atoms. This type of bond happens between non-metals only. So let's have our first example. One good example of non-metal is the hydrogen atom. Although the hydrogen atom is found in the group 1 element, hydrogen is a non-metal because it is a gas. Since it belongs to the group 1 element, it has one valence electron. Hydrogen can bond to itself. And so, let's have another hydrogen here. When we have covalent bonding, it's different from ionic bonding that it is signified by an arrow. Instead, bonding is signified by a line connecting the valence electrons. And so, when we represent the covalent bond between two atoms of hydrogen, we simply write a line connecting the two valence electrons. And so, we have hydrogen here, and then another hydrogen here. Remember that in order for elements to be stable, it needs to follow the noble gas configuration. Remember that the noble gas configuration could either be 2 or 8. In the case of hydrogen, it doesn't follow the octet rule because it follows the noble gas configuration of the element helium, which has 2 valence electrons only in the first energy level, which is already completely filled up. And to represent the bonding, you just have to write a line connecting the two dots. So that is now the bond between hydrogen. Let's have the second example. The second example would be bonding between carbon and hydrogen. So let's go back to our periodic table of elements to see how many valence electrons does carbon have and hydrogen. So obviously hydrogen has only one, while carbon has 4. 1, 2, 3, 4. So let's write now the Lewis dot notation for carbon. Since carbon has 4, so we'll write it around the element symbol, carbon. And since hydrogen has 1, and it needs to follow the octet rule, which is 8 valence electron, there is no transfer of electron, rather sharing only of electrons, thus the use of the line. Since carbon needs 4 more electrons, we also need 4 more hydrogen to bond with it. Thus, we are going to draw this one. And covalent bond will never be complete without connecting the dots. And so we now have the chemical bond for carbon and hydrogen, which results to the formation of methane, CH4. Let's have the third example. The third example is phosphorus and chlorine. Let us see from the periodic table of elements the valence electrons for phosphorus and chlorine. Phosphorus belongs to the group 5, so that means it has 5 valence electrons, while chlorine has 7 valence electrons. So let us now write the valence electrons, the Lewis dot notation for phosphorus. We have 1, 2, 3, 4, 5. And then for chlorine, we have 7. 1, 2, 3, 4, 5, 6, 7. There is no transfer of electrons, only sharing of electrons. Now chlorine, in order for it to attain the noble gas configuration, it only needs 1 more electrons. And so this unpaired electron will pair to this one, making chlorine a stable element. But phosphorus is not yet stable. It still needs other element to bond with it. Phosphorus tend to bond with three chlorines or five more chlorines. In this case, since we will be following the octet rule, there is one lone pair here, while the three will need to pair with another chlorine. And then another chlorine here. So making the valence electrons for phosphorus 8. 1, 2, 3, 4, 5, 6, 7, 8. So it has already attained its octet rule and making it stable. So let me just rewrite. Let's make phosphorus as the center of the molecule. So let us put the phosphorus at the center. And then the chlorine here. Let's just connect the dots. Connecting the dots. Now this molecule is PCl3 or phosphorus trichloride. So that is now what we call covalent bonding.